Hey everybody. The goal in this video is to take what we've learned with long division and eventually use that to fully factor and solve a polynomial. So to do that, to solve it, you're probably going to need this, the quadratic formula. Sometimes whenever you build a quadratic out of this, it's not going to be able to be factored. And so you'll just solve that quadratic using, again, the quadratic formula. So for this first question, find all solutions to this function that's equal to 2x cubed minus 11x squared plus 25, given we know that x minus 5 is a factor. Now we're finding all the zeros or all the solutions to this function, and it's really easy to determine how many you're trying to find. We know that the largest exponent is 3, which means the degree of the polynomial is 3, which also means we're going to end up having 3 solutions. So I'll just go ahead and jot that down right now. X equals, and x equals. Again, we know we're going to find 3 solutions altogether because this is a cubic function or a third degree polynomial. The number of solutions always match. Now, we also know one of the solutions right off the bat. If something is a factor, then that factor equal to 0 is going to give you one of the zeros. If something's a factor, that's great. It means we pretty much have a solution. So to find our first solution, again, you can just set the factor equal to 0 and solve. So x equals 5. That is one of the solutions. Go ahead and list it over here next to my solution box. All right, now to find the rest, we don't have a way of dealing with this cubic function to pull the zeros out just right off the bat. You can try graphing it, but if you get imaginary solutions, those solutions are not going to appear on the graph, and that's why we're going to need this quadratic formula. Now, to break this down and find those imaginary solutions, remember, we can use long division to make this cubic function turn into a quadratic function. So let's do that. One other good thing about being a factor is when we do long division and we divide the function by x minus 5, we're going to have a remainder of 0. That means we're going to have a perfect quadratic to work with. So let's go ahead and do some long division. I'm actually just going to do synthetic division to make this go a little quicker. Remember synthetic division, you just set up that template first. Kind of looks like that. Put a little box down here in the bottom right. The value that goes here is the solution to this factor. So it's not negative 5 that you write here, it's actually going to be positive 5. And then you can list all the coefficients here. So we've got 2 minus 11 and plus 0. Because we're missing a term, we go from x cubed to x squared to x, and then 25. All right, when you get the template all set up for long division, you put in the factor, you list all the coefficients. To start it off, you just drop down the first term. So 5 times 2 gives me positive 10. Negative 11 plus 10 is going to give me negative 1. Negative 1 times 5 is negative 1. 0 minus 1 is negative 1. Negative 1 times 5 is negative 5. What did I do wrong here? That is, hey, sorry for my mistake. So we've actually got negative 1 times 5 is not negative 1. Negative 1 times 5 is negative 5. 0 minus 5 is negative 5. Negative 5 times 5 is negative 25. And that's how I said we got the remainder of 0, which again means x minus 5 is a factor. All right, so we've got our quadratic pretty much built. It is 2x squared minus x minus 5. So with this quadratic, remember, the goal here is to try to find the solutions of it now. All we've done so far with long division is maybe write the factor, getting multiplied by the quadratic that we built, and then we're done. So to get the solutions from this, you can try to factor it. You can try to factor it using like the AC method, factors of negative 10 that add up to negative 1. But I think you're going to have a hard time if you try to do that. So if you get the quadratic, remember, this method never fails. You can always apply the quadratic formula, and that's what I'm going to do to this. So x equals, I was following this, negative negative 1, because that's my b value, plus or minus the square root of b squared minus 4 times a times c. All of that will be divided by 2 times a. The value of a is 2. It's the first value in our quadratic. To get the solutions then, we just need to work on simplifying this. X equals 1 plus or minus square root of, hey, so negative 1 squared is actually positive 1. So I'm doing negative 1 times negative 1. And then all of this, so I've got negative 4 times 2 is negative 8. And then negative 8 times negative 5 is positive 40. All that will be divided by 4. Okay, we keep going. All right, so this is your exact solution. The square root of 41, that's not a perfect square. So you're going to get a decimal that never ends. That is an irrational number, but we can approximate to make the answer make a little bit more sense. So we could do the second square root of 41, which is pretty close to 6.4. Again, this decimal is never going to end. So after taking the square root, we're just approximating, but still, I think it helps make the answer easy to interpret at least. So we're going to have x equals 1 plus 6.4 divided by 4. And we're going to have x equals 1 minus 6.4 divided by 4. I'll just do those on a calculator. 1 plus 6.4 divided by 6.4. I get approximately 1.2. And then on this other piece, I'm doing 1 minus 6.4, dividing that by 4. And I get negative 1.35. I'm just going to round it up to 1.4. So there's 2 of our solutions. Remember, we already had one from the factor that was given to us. And we didn't actually end up with any imaginary solutions this time, but you wouldn't have been able to get these results by factoring. 1.2, it's approximately negative 1.4. And there are all 3 zeros of that cubic function. All right, so we'll cover some more problems like this during a Zoom class. Otherwise, enjoy your day. Thanks for watching. Bye-bye.